Hi there, this is Juan Rivera, and that's a shot of me making an approach into Hap Miller's ranch up in the Sierras. A word of warning, this is the third time I've tried to do this video. Either the phone rings or someone bangs on the door or something else goes wrong. I don't have the patience to produce a perfect video, so I'm just going to press on no matter what happens. So here we go. So the reason I'm doing this video is I sell a set of custom replacement instruments for the Helicycle. And I wanted to contrast the ones I sell with the stock instruments that come with your kit. Before we leave this particular picture, which I'm very fond of, I just wanted to encourage all the builders that are frustrated and waiting for parts from the factory and can't get anybody to answer the phone. Eventually, this will be you someday. So take the long view, hang in there. Eventually you'll be flying around going, well, it was worth it. Now I've got my Helicycle. It's a beautiful machine and I'm having the time of my life. So hang in there. And if you don't have patience and you don't take the long view, I have a kit for sale, which probably will save you 5 or 6 years waiting for parts. If you're interested, you'll find everything there is to know about it on my website at helicycles.org. Okay, here we go. So here's another shot. I'm flying around in the south end of the San Francisco Bay. I picked this one because it shows the upper and the lower instrument panels and what my panels look like on my first ship. All these pictures were probably taken in 2013, and that was 750 Golf. Now it's on its fourth owner and it's still going strong as far as I know. So the thing to remember here is you're going to get some sheets of blank aluminum. You're going to get a drawing that you can use to cut out these shapes. And you're going to get a sack of instruments. Whatever you do is up to you. The shapes will be as you see here unless you want to throw that pod out and start over. So whatever you can fit in these shapes, there you go. Let's take a closer look at the upper panel on this particular ship. So there it is. This is before I came up with my custom instruments, so you're looking at instruments that either came with it or were commercial off the shelf. Let's start over here. This is a VSI. That's stock off the shelf. Airspeed, stock off the shelf. Altimeter, commercial off the shelf. All came from Aircraft Spruce, as did these tasteful colored arcs of stick-on vinyl that I stuck over the outside of the instruments so that I could make some intelligent use of them. The instruments that come with the kit are this dual engine oil temp oil pressure, transmission oil temp, exhaust gas temperature, rotor RPM, tachometer. This guy over here is a digital fuel flow indicator that I bought also from Aircraft Spruce. So the instruments that come from the factory are these four here, plus fuel quantity and a dual voltmeter ammeter, which went on the lower panel. Everything else, it's up to you what you do. So after building this kit and flying it around for a while, I was so dissatisfied with these stock instruments and my stick-on vinyl arcs, I decided to come up with a custom set of instruments for the Helicycle. I have UMA Instruments build them for me, resell them to you guys, and help you spiff up your kit. Let's take a look at the panel I came up with. So this is my Generation 2 panel with my custom instruments in it. It never ended up in my kit because by the time I got started on that kit, my eyesight had gone bad and I can't fly anymore. So this is now residing in a local builder's helicopter in my garage. Now, let's take another look. So you'll notice, first of all, there are no more stick-on vinyl. All of the colored arcs are inside the instruments where they belong. Where did they all come from? Okay, so this is the same old stock VSI indicator from Aircraft Spruce. This is the same altimeter I used. It's a different one, but it's the same type. These instruments here, these 5, are custom by me. This guy here is a custom instrument that Doug sells. It's a dual stepping motor tack with rotor and engine RPM on it. So if you use that tack, you don't need the Red Lion digital tack during flight. What I've done on the customer kit is I've got a 9-pin D-sub connector, and it's right there on the box that houses the engine governor. During ground maintenance and setup, you can plug that Red Lion in to that connector and use it just as most people would do with the one that's in their panel. But once you're done, unplug that sucker, coil the cord up, and tuck it away. You don't need it in flight because you've got the engine tack up there in the upper right. One thing I wanted to call your attention to before I change to the next slide is how easy it is to see the needles on these instruments that I'm selling. They're big, they're fat. The same goes for the alphanumerics and the tick marks. Everything is a lot bolder and easier to see. You'll see this in the next slide. I put the two areas of the two panels side by side. So look at that. So let's start over on the upper left. As I say, the stock Helicycle does not come with fuel flow indicator or a transducer, but I wanted one, so I bought this. I think it's called an FS450. It's an ideal instrument for fixed wing where you can climb up to cruise altitude, click on the autopilot, turn the music up, get your sandwich and your thermos bottle out, have a nice lunch, and then you can leisurely play with this indicator. You can poke the button and you can switch around and you can look at time remaining to next waypoint, on and on and on. In the Heli-Cycle, I think it's 100% useless. It's just a total waste of money. So I replaced that with the one you see directly below, which is an analog indicator. Now, a couple things about that. Fuel flow is proportional to transmission torque, and it's also related to horsepower. The main thing we're concerned with, and I tried to find BJ's video so I could post it, but I don't know where it went. He did a video a few years before he died discussing the design of his transmission. And in that, he mentions that the transmission input torque is limited, I think it was 650 foot-pounds. It's been a while and I may have that number wrong. But using math, you can convert that. You crank in the gear ratio, the foot-pound limit, you come up with horsepower. Once you get to horsepower, that came out 90 or 91, I think it was. I added another 10 for all the accessories and the tail rotor, came up with 100 horsepower. So I'm saying that's the limit. The engine's capable of putting out 160. You do not want to go past 100 because you're going to overstress the transmission and greatly reduce its longevity and its reliability. So now we take that number, we go into the factory maintenance or overhaul manuals for the solar engine, and there's a graph in there, and you can use that to convert to gallons per hour. And that comes out 15.9 gallons per hour. When you get there, you're maxed out. And so you'll notice I have a red arc that starts right there. And like all of the red arcs and red lines that you see on any of my instruments, they all drive an external alarm. And the big ones, like this one in the EGT, also have an internal LED. See that down at the bottom. So I think that's a very, very useful instrument. Now, what's wrong with the digital one? Digital's fine if you've got time to stare at it, and it's steady. It's not doing anything. But in the helicopter, let's say you're pulling collective to get ready to take off. It's going from idle of 4 or 5 gallons per hour up to about 13.5 when you finally get off the ground. If you were trying to get any useful information out of that digital tach, you'd just be looking at a pinball machine full of numbers flashing around in there. It's just useless. But with the analog tach, with that 270-degree sweep, it's very easy to go, okay, I'm up to 9, 10, okay, maybe it's going to start getting a little light on the skids. We're up to 11, okay, I better start looking at the skids and see if I've got a little yaw going on. Oh, I saw the skid move to the left a little bit. I'll give a little pedal to correct that, and that's how you work your way up off the ground. At least that's what I would do. So it was very useful to watch that fuel flow inch up as I pull up on the collective. With the digital one, good luck. So everywhere you see red, there's an alarm. So if you count them up, left to right, 1, 2 for transmission oil temp, 3 for engine oil temp, 4, 5 for engine oil pressure, because too low is just as bad as too much. And then 1 for EGT. And that one is at 1180, which is the EGT limit per the factory manual on the engine. So all told, we've got how many? 1, 2, 3, 4, 5, 6. Did I do that right? 1, 2, 3, 4, 5. 6 alarm outputs just from those instruments. Now, not shown are the instruments down on the lower panel. So we have fuel quantity, fuel pressure, voltmeter, and an ammeter. The voltmeter also has 2 outputs, a red line for too low and another one for too high. Too low would be if your generator, your alternator died. Too high would be if the thing went nuts. With a stock system, it wouldn't matter because it's so anemic it can't do anything. But I have a 55 amp alternator conversion, and if that went nuts, it could overcharge the battery. So all told, I've got 4 more alarms coming off the lower panel. That's a total of 10 alarms, not even counting the clutch and the chip detectors. So that's a lot of alarms. And what I do is, if you see all these lights down in the bottom here, I have a board that I was selling, and if there's enough interest, I'll do it again, called a crew alerting system, or CAS. And all it was really diode logic driving little read relays on a small circuit board. And so, for example, this engine light would be driven by engine oil temp being in the red line, engine oil pressure being either too low or too high, or exhaust gas temperature hitting the red line. So all of those inputs, 1, 2, 3, 4, all get OR'd together and drive that engine warning light. And the way an OR gate works is you've got multiple inputs and 1 output. And basically what it says is if input 1 goes high, or is, let's just call it an alarm. If there's an alarm on input 1, I'm going to send an output out. Or if there's an alarm on 2, or on 3, or on 4, or any combination of those, if any of them have an alarm condition, I'm going to light that engine light. So that takes care of those. The fuel next to it is driven by fuel quantity and fuel pressure. The alternator, you guys don't need to worry about that, but I have an alternator, so I just use the idiot light, run it up there. The volt one is either too high or too low off the voltmeter. Clutch, everybody's got that, so you've got your switch on the clutch that tells you when you're fully engaged or when you're not. So fully engaged, I've got a green light that comes on, says we're good to go. If it's not, then this red one comes on and says it's not, don't fly. The transmission one takes a little explanation. So we have transmission temperature. If that gets too hot, that will light the transmission one. Also, fuel flow. As I said, fuel flow is related to power and torque. And so when we get up to a fuel flow of 15.9 gallons per hour, we're maxing out the transmission. So that one goes to the transmission light, and then chip detectors to chip. So that's what you can do with these instruments that you cannot do with the stock ones, because the only alarm on the stock ones is low fuel. That's the only instrument that has anything. Okie dokie, on to the next one. So now let's take these one by one. So what's the difference between the stock ones and the custom ones that I sell? The stock ones are all 90-degree sweep. Mine are all 270. So I've got 3 times as much arc to work with. So that tends to expand the scale out. These are the same size. It's almost an optical illusion. You'd swear that mine is much bigger, but they're not. I've tried to line up the screw holes when I put this together. But you can see that there's just a huge difference in readability. Now, in the case of these, both of them have warning LEDs, and you see the ones lit on the stock instrument, and they both have external alarm outputs. The fuel quantity stock instrument is the only one that has an alarm output. That's it. Here's EGT. This is a great example. I think mine is 1,000 times better than the stock one. So let's say you're flying along and the temperature you think is around 1,000 maybe, or 1,100. Look on that stock gauge. Can you really tell the difference? First of all, my tape is in the way, so you can't really see the lines anymore. But, that's like, I don't know, 1/16 of an inch between those tick marks. How do you know when you've got to 1180, which is the red line? And if you're not staring, how do you know you didn't go right past it? Well, with mine, it's going to light an alarm. That's how you're going to know. And it's pretty easy to tell the difference between 1,000 and 1,100 degrees. It's about half an inch of movement on that needle. So again, I think it's just a huge improvement. Here I don't sell a replacement, but Doug does. But what I wanted to show you with this stock instrument is I borrowed a function generator from work, extremely accurate, down to parts per million. And I adjusted the input on the left to low rotor. So that's sitting at 610. That's the low end of the green zone. The one on the right is 620 RPM, the high end of the green zone. Look at the difference. It's maybe one needle width. So if you had colored arcs on there, that arc would be the width of that needle. It's totally useless. It really is. And then to make matters worse, if you look at the back of this thing, there's a little hole. Stick your screwdriver in there, you can adjust it and make it say anything you want. It doesn't care. And lastly, it's an analog meter, so as components age, it's probably going to drift. And how are you going to know that it's off? Unless you have some test equipment. So Doug's coming out with a new version. That's why I didn't put the old one up here. It's got an expanded scale. It's dual tack engine and rotor, stepping motor, digital technology, and it has high and low rotor alarms. And I think that's critically important. Even with an expanded scale, it's going to be hard to really pay that much attention to these things and make sure that you're still in the green. There's nothing like a big idiot light. So once I get one of Doug's tacks, I'll take a picture and I'll stick it in here. Here's fuel flow. I went over that earlier, but here they are side by side. And if you do a little test, and my eyesight's not very good, so you'll have to adjust for your own. But say you focus your eye on the period on the first line after indicator. Stare at that. Maintain your vision right on that dot. Now tell me what that digital indicator says. What are those numbers up there? You can't really tell, can you? If you can, then your eyes are, a lot better than mine, so go down a line or two. But reach a point where you can see it out of your peripheral vision, but your brain can't make anything out of it. Now, without moving from that spot, I ask you, where's the needle on the analog one on the right? I can see that. And so my point is, out of your peripheral vision, it's pretty simple for your brain to go, okay, is that needle in the green or not? Is there a trend? Is it going up? Is it going down? With a digital one, if it's going up or down, all you see is a pinball of numbers jumping around in there that mean nothing till it stabilizes. And the way your brain works, because of my particular vision impairment, I'm now a world expert on this. For your brain to be able to interpret text or numbers, you have to stare right at the middle and put that image in the center of your eye in an area called the macula. That's where the highest concentration of rods and cones are, and that's where your brain is set up to interpret what you read. So when you're reading, you're putting the words that you're trying to interpret into the macula in the center of your vision. You can still see everything in that paragraph down there by staring at the middle of it, but you can't read it. If you don't move your eye, you know they're words, you know there's 5 lines, but you can't read but a couple of them right in the middle. So that's the problem with digital. You have to go through that extra step. Your optic nerve takes a picture, shoots it up to your brain. Then your brain, if it's analog, it goes, well, is it in the green or not? Okay, we're done. If it's digital, it's got to go, oh, geez, what's going on? These numbers are jumping around. Okay, now they're steady. Well, what is the number? What does that mean? So it takes a lot more work. Enough said. Okay, here we have transmission temperature. Same thing. These are these little guys that I sell. It's a 1 1/4 inch. And even though it's small, it's still more readable than the big one. And I've gone out of my way to try and adjust the brightness of the white so that I'm not taking advantage here. I've tried to make them both the same, but because the font is thicker and the arcs are much more brilliant and the needle is so much fatter, these indicators are just really easy to read. Same thing here. So this is oil pressure and oil temperature. This is, even more confusing once you put some arcs on there so you know what you're doing. the clutter of these two little cat whisker needles and the arcs that I stuck on there, it's a mess, and it's not easy to know what you're doing. So I replaced that thing with the two you see on the right. And again, instead of a 90-degree sweep, they're 270. They're just much easier to see. I'll stop beating you over the head. Here we have the voltmeter and the ammeter that would normally be on your lower panel, and my replacements on the right. And again, I have two red lines on the voltmeter. Anything below 11, I say that's a problem. Anything over 15, another problem. So either one of those will light that volt light at the top of my panel. I think the last one is a new one. I don't have an actual instrument yet. It's in shipment. It's going to be fuel pressure. This is the artwork for it. I'll replace this with an actual picture once I get it, probably in a week. So this will be another one. And again, anything less than 4 psi, you'll have a fuel alarm, and that would be OR'd with the low fuel alarm off the fuel quantity indicator. Now, before I go to the next slide, what I do on my cast board is I then take all of these lights that I already showed you, and I think there's 7. Actually, there's more because I have high rotor, low rotor on another part of the panel. So there's 8 or 9 lights. Each one is driven by one or more alarms. So for example, volt could either be high or low voltage, etc. Those then all get OR'd together, and they drive a magnetic latching relay. And so even if you have a momentary glitch, if it momentarily hits an alarm condition, it will latch that relay. That one in turn drives a 4-watt master caution and warning annunciator at the very, very top of my instrument panel. And that will stay lit until you reset it with a button on my cyclic grip. And so why would you want to do that? On my website, I just added a good description of a common problem dealing with oil flow in the engine. You have the oil pump, the engine oil pump, inside the engine, which is pulling oil out of the external sump and feeding it into the engine. Then, being driven by an accessory drive on the outside of the case, are 2 scavenger pumps that are pulling oil back out and sending it back where it came from to the external sump. Now, what can happen, depending on how healthy that internal oil pump is it may have more capacity than the capacity of those 2 combined scavenge pumps. And what happens is oil builds up in the engine. And what that does is it starts to cause the engine to overheat, because oil is being sucked up into the gear reductions, gearbox, causing excess friction. And also you get bubbles in the air and the oil. And so what you see on your instruments, and this happened to me, so that's why I'm telling you this, I know it for a fact, is I had intermittent fluctuations in oil pressure. It would be rock solid, and then it would just go nuts for a couple seconds. It would jump all over the place, and then it would go back and be rock solid. And so maybe you think you saw something out of the corner of your eye. You stare back down there at that instrument, you go, oh, I must have imagined something. It looks fine now. Well, if you have my cast system, even an intermittent glitch like that would at least intermittently would light the engine warning light. That would flicker on and off as these glitches went into the red. But even the first little flicker would latch that master warning light, and it would stay lit. So that's your warning. If you look down and everything looks fine, but that's lit, there was something that happened and now it's gone. But at least you're alert to that fact. So that's what all these indicators are designed to do, and that's what that CAS board tried to take advantage of, the capabilities of all these alarms coming out of these instruments. Last, I think, is the airspeed. So this again is a custom one, and it's got silkscreen arc inside it for the Helicycle. And I should mention, thank you to Doug, one of the two Helicycle test pilots. All of the range of the various arcs and all of my instruments I passed through Doug to get his blessing. Last time I talked to him, he'd test flown at least 70 Helicycles. So I think he's the man. And so this, like all the other ones, is based on input from Doug. Here are the mechanical dimensions for the various size indicators. So the big ones I sell are 2¼ inches. All of these have EMI shield enclosures. They're all made out of aluminum. And the connector on the back is an EMI shielded D sub. The stock connectors are all housed in plastic containers. And the ones that have electronics in them are susceptible to getting interfered with by any sort of interference that is either radiated or conducted. So these are much more bulletproof in terms of susceptibility to interference, much less. So these are the bigger ones. Here's the smaller ones. These are those little guys I showed you that are 1¼ And that's the end of that. So I hope you enjoyed this. I hope you haven't lost complete faith in getting your kit together. And if you're thinking about getting one, just know that it takes many years to get all of the parts from the factory if you buy a new one. So again, I have one for sale. It has everything you need, so you don't have to wait. Look on my website for that and a lot of other information. So thanks for watching. And the website is www.helicycles.org. Thank you.